Hi everyone, my name is Akshaj. Till now we have built the FastAPI app itself. So this video will talk about something different. We'll talk about Docker and how you can Dockerize your own FastAPI application. Right. So you may ask that what does Docker solve? Your app works because of a very specific combination of things on your machine. Python version, your installed packages, your OS level libraries and environment variables. If you move the same code to a teammate's laptop or a server, and any of these one things being slightly different, it can break it. What does Docker solve is that it tells us that don't just ship the code, you could rather ship the entire environment the code needs to run, packaged as one single thing. Two words you'll hear constantly in this video are image and container. An image you can think of is like a recipe, a frozen snapshot of everything you need to run the app, the OS, Python, your dependencies, and your code. A container, on the other hand, what happens when you actually run the recipe, a live running instance of it. So one image runs twice, gives you two separate containers. You can think it of the same relationship you have as a class and an object if you have seen the previous videos, right? So we are here at the VS Code app, and I have created a folder, and I've also created a virtual environment, and next I've created a file called requirements.txt, right? We have two packages, FastAPI and UVCon. This file requirements.txt matters here more than it must have before, because inside the container there is no pre-existing Python environment with the packages already installed, because Docker starts from nothing. So this file is now Docker knows is what to install, right? So I have already installed it in my local setup using pip install -r requirements.txt. So we'll start by creating a file called main.py. Okay, so what I'm going to do is I'm going to paste the code I've already written before, and nothing new here if you have seen the previous videos. It just has two endpoints, a root and a path parameter. The interesting part today is not about this file, it is rather everything around it. So what I'm going to do is I am going to run this file in my term. So I'm going to copy this one and I am going to paste it in my, yep. So this confirms that the app actually works outside Docker. Now let's put it inside a container and prove it still works the exact same way. Okay. So I'm going to create a file called Docker file, and I'm going to copy some code I've written before. Okay. So let me explain what this file actually explains. Okay. So if you see the first line, you may ask that what is this? Because every Docker file starts from a base image, and an existing image you build on top of it instead of starting from a completely blank one. Okay, so Python 3.11 Slim is basically has Python 3.11 installed on a lightweight Linux space. And if you slim is basically, it just means that it has been trimmed down. It has a smaller image because it's faster to download and build, right? The next line is work directory /app. This sets the working directory inside the container. You can think it of as cd/app. Every instruction after this runs from that folder. Okay. If you see next two lines, this copy requirements.txt basically we copy requirements.txt and install dependencies before copying the rest of the code. Docker builds in layers and caches each one. And if you change main.py later, Docker sees requirements.txt has not changed and skips reinstalling everything. Your rebuilds like this become much more faster. You copy the code first and you lose all that before without caching. If you see the next one, this one copy dash dash, you just copy the entire folder like main.py inside that, and everything else gets copied. Expose 8000, basically this document which ports the app listens on inside the container. It's informational because it does not actually open the port to the outside world by itself. It later happens when you run docker run. Okay. Now what we'll do is that we'll build the image. So I'll open a new terminal from here and I'll write this code. docker build -t and with the file name folder name I have. Okay, so let me explain what this line does. Docker build reads the Docker file and actually creates the image, running each instruction we just walked through before, layer by layer. The -t here is basically tags it with a name so we can refer to it later instead of a random ID. The dot at the end, you see, just means build context is inside the current folder. So when I run this one, it takes some time to load, and as you see, what is that? If I say allow, okay, you can literally see each Docker file line executing in order. So pulling the base image, installing dependencies, and copying files. So it'll take some time, and it has done everything. So if I write something called as Docker images and hit install, so this lists every image on our machine. There's ours, name, tag, image ID, size. This confirms the build actually produced something before we can try to run it. Okay. Next thing we'll do is that we'll run the container and do port mapping. So I'm going to paste this line here, and we're going to see what it actually does. Okay. Let's break this down. -d here runs the background, detached. So you get your terminal back. The -- name gives the container a name instead of a random one and is easy to reference later. And -p 8000 to 8000 is port mapping. This piece actually connects the outside world to the container. Here's the thing to understand about port mapping. The container has its own isolated network. So port 8000 inside the container is not automatically reachable from your machine. -p 8000 to 8000 means take requests hitting port 800 on my actual machine and put forward them to port 8000 inside the container. This format is always host port to container port. They don't even have to match. -p 9000 to 9000 will actually mean reach the container at localhost 9000 on my machine, even though it's still listening to 8000. So when I try to run this, I will go to my thing and write it again. And if you see, here's a message that we have a Docker application of Super 30. And now what I'm going to do is I am going to write a new one. So have you seen before in main.py, we had this like this. Okay, so what I'm going to do is I'm going to write this and write my name Akshaj. So when I try to run this one, this path parameter works the exactly same. So and when I see when I try to show you the Swagger UI, and just a minute. FastAPI generates this automatically from your code. No extra setup. You can expand each endpoint, and if you try hit it out, and actually call the API straight from the browser. It's great for testing and without writing any curl commands every single time. So let's expect our running containers. So I'm going to write docker ps. This shows every container that's actually running, container ID, the image it's from, when it started, and importantly the port mapping we just set up. So you can double and check it actually. And next what I'm going to do is I'm going to write this one. Okay. Right. This will have a give me an issue because my container name is Dockerized FastAPI container. So next what I'm going to do is I'm going to write this one, right? Dockerized FastAPI container. So this shows the container's console input, output, and exactly what you have seen in the terminal if you run it without -t. It's the first page to check if something's broken. So let's now stop the Docker and start cleanup, right? So I'm going to write docker stop Dockerized FastAPI container. And when I write docker ps, docker stop actually shuts the container down, but it is not logged. If you see Docker PS, it only shows the running container. And when I write Docker PS minus A, it shows everything running or not. So if I start to start the container again, all I have to do is Docker start, and when I write over here instead, enter, and what I do next is I'll write curl. So what Docker start brings is that Docker start does is that it brings the exact same container back, same name, same state, no label needed. The difference between run and start is that run creates a brand new container from an image, and start basically resumes one that actually exists from before. So if you see here, we got the same message we saw in the browser before here, right? And if I try to stop it in my terminal, all I have to do is, instead of this, I have to write docker stop, and I'll copy this one and hit enter. It stops. So that was the video, and let's now recap what we have learned. So Docker image is a frozen snapshot of an app plus everything it needs to run. Docker container is a live running instance of the image. Docker file is a set of instructions that builds the image. Base image is the starting point you built on top of. Python 3.11 Slim here we used. Port mapping is something that is connecting a port on your machine to a port that is inside a container, so the outside world can actually reach it. And for the commands, we have talked about Docker build that creates an image from Docker file. Docker images lists the images you have locally. Docker run creates and starts a new container. Docker PS stores running containers. Docker logs show containers output, and Docker stop holds a container without deleting it. And that is the full stop. So from a plain FastAPI app to we have built something packaged, portable, and runnable anywhere using Docker. So if you get stuck in any step, that is important to know is that the error message from Docker logs is almost always the faster way to figure it out. So that was the video. If you liked it, so please like, share, and subscribe, and I'll see you in the next one. Thank you.